And the idea is that we're going to discuss three things. First, why do we want to do R packages? And the reason for that is we can document our code in a standard format, and it makes it easier for others to discover the code. And so I think that's important for this data science reproducibility thing. And so in particular, this makes it easy for people to discover how to install your code, how to use it, and how to discover how it works. Second part of the talk, Git commands, I'm going to only discuss very briefly. So we'll skip about like 20 slides there. But for your reference, I created like a couple of slides to explain, how to, use Git on your own computer to, commit the changes and push them to GitHub. And then the last part of the talk, code review on GitHub. This is going to be like the kind of goal so that we can use pull requests for making it easier for others to review your proposed changes to the code and ask questions, suggest improvements so that our team can better understand and maintain the shared code that we need to work on. So this is kind of like the overview. Do you guys have any questions before we get started?
I may vote for a little more Git commands and a little less R packaging if I can, but I don't know if I have a vote.
Okay.
For the Python, since we're going to be as equal, we're going to be doing a lot of Python coding also. So.
Well, I guess we could do that. There's also a video that we already recorded with the Git command, so that's the reason why I was going to skip it. So we already have like 10 or 15 you can watch.
Gotcha. Yeah. It was just
Anyway, so why R packages? First, what is R? This is a programming language and software system for statistical computing. Here's a bunch of links if you want to install R. I recommend that you use one of these editors, like Emacs Speak Statistics is my favorite. There's other IDEs like RStudio, Positron, VS Code. Please don't use just like regular R without an IDE. The power of R comes from its 20,000 plus packages. Each one provides a different data set or statistical algorithm or several. And every one of these has a standard documentation for everything. So this is super powerful. Anybody can write a package and upload it to the central repository, and all the packages are continually checked for compatibility with another. So all the current version of the packages are always guaranteed to work with each other. So that's really kind of a unique and awesome feature of R. So what is an R package? Well, we have some R code in various scripts, and I give some links to a couple of these repositories. They both work, but neither are easy to understand nor to modify. So the idea is that we want to convert this code to an R package, which is organizing the code and adding documentations and tests to make sure the code works in some specific situations. And R packages has standard file structure, so it's easier to understand and modify, and it's also easier for others to install. And so I have a link to the proposed R package that is for the National Survey of Children's Health data. And so my recommendations for our machine learning paper about this data. So I would say most of the data related code should go into functions in this R package. So functions for downloading the data from the website and combining the data across years. I would put all of that stuff in there. Then most of the machine learning code goes into another repository, which I would call a lab notebook. And so I have an outline here where you could have a bunch of R scripts which use that package for various analyses and figures for the paper. We could put all the data files in a subdirectory like NSCH data, and then you can have subfolders to easily audit each data processing step. For example, my current code has these first two directories like 00 original stata for the original stata data files downloaded from the website, and then 01 original CSV for converting all that data to CSV for kind of like more easily and portably reading it. And then after that, we can imagine other steps like decoding the different variables and then combining the years and then a one-hot encoding for the machine learning analysis. I haven't done those last 2, 3, and 4 steps, but that's something that I think would be useful because then we could have, easy way to check between the different steps if the data sets are compatible with each other or if there's some like mistake that was made. So what do I mean by this lab notebook? So I have these lab notebook repositories where Here's the example that I created for this project a few days ago. I put a README with a date for each day that you worked on the project, most recent date on top, and then you can have a link to the code files that you're working on. You can show some result figures on the README, and you can write your interpretation for each of the result figures. And so why do I do this? Just so that we have like some kind of record every time we work on it. Eventually, we can move some of this NSCH data related code from a like lab notebook style repository like this to the R package. But as we're working, I recommend like doing some kind of organization, like using a kind of a GitHub README or something similar, so we can keep track of, you know, what are the different files and what are they doing, what are the different figures that we're creating, what is our interpretation of these results. For this figure, I think I have another slide about this. Like, for example, if we want to zoom in on this, this is a figure that analyzes the consistency between years. So on the y-axis, we have the response for one of these survey questions. The survey question here is K6Q71R, which means interest, curiosity, or show interest and curiosity, depending on the year, the name of the variable changed. And why do I choose this variable? This is one that with Vince last year, we had some issues because there was some problem consistency between the years, right? We see on the x-axis different years between 2016 to 2024. We see that the first 2 years have like different responses than 2018 and onwards. So, you know, we can use figures like this for kind of verifying if we get, you know, as we do the different data processing steps, hopefully we could see this inconsistency go away, right? So we could run this analysis before and after the, for example, the combining year step. And so hopefully after combining the years, we could see that this question and other questions are standardized to have the same kind of responses rather than hear different responses in the first 2 years and from the other years. Does that make sense? Does anybody have any questions about that figure?
No, it's clear.
Okay. Yeah, the entries of the matrix are the percentages. I didn't mention that. Anyway, so the idea would be to make some different functions for doing these different kinds of data processing and checking operations in the R package. And so what do we do with the R package? To install it, we would do install.package as NSCH after we put it on CRAN, but it's not on CRAN yet. So to install it, you would have to do install_GitHub here if you wanted to install from the main branch, but there's nothing on the main branch right now. So here, if you want to actually install anything, you have to do this @download-funds, which means to download from the download funds branch where I have pushed some code. And if you do that, you get some output like this, which shows that you would be installing the package on your computer. After that, what is the one thing that we have in the package so far? I have one function that I wrote. The one function is get NSCH index. When you run it, it looks like this. It gives you a table with 9 rows and 2 columns, URL and year. So you get one row for every year of data that is currently available on the NSCH website. So this is something that we can use to download all of the current data if we want. And so this is, along with this function, we also get documentation for the function, right? So this function get NSCH index, we have a plain text documentation here. We have an HTML page. There's other ways of rendering the package documentation, but the idea is that we can get some description of here, how is it we typically using it? What is the description of what the function is for? What are the arguments to the function? And what is the value that it returns? You also have usually at least one example about how to use the function, some R code that you could run to see how it works. So that's the man page documenting the code. And so our package is basically a folder with a bunch of files in a standard format. The most important subfolders are R for the R code and man for the help pages that like we were just looking at. documenting each function. And then you can also put tests here for test cases, code that makes sure functions work as intended. So before we go on, though, are any questions about just here this example usage and the man page and the package structure? Okay, well, let's keep going. So in our subfolder, you put R files. So git nsch index.r has this our code here, and we define a function, and then we can call that function later when we want to use the R package. This is the function for downloading the table of years of available data. The man pages, there's this markup format, which is kind of based on LaTeX, where we have this like kind of backslash name, backslash alias, backslash title, backslash description, backslash usage, arguments, value, author examples. So all of this stuff is pretty straightforward. You just put the text that you want in the corresponding section, and then it gets rendered to the different kinds of man pages that you can access in R. After that, there's this tests folder. In the test folder, I recommend using this test that framework for testing. And so what do we do with tests? We're going to run our functions with known inputs, and we make sure that we get the expected output. So the code here says test that year column is int. And so the first thing we do inside of this block is we're running nsch get nsch index, and we give it system file package nsch x data datasets.html must work equals true. What it is doing is running this one function on this existing HTML page that we've downloaded, we put inside of the package, because usually when you're doing package tests and examples, you don't want to actually do any downloading. You want to be doing everything on data that's already in the package. So here we're running it on this file that I've already downloaded and put inside the package. You get this years DT as an output, and then it says expect identical years DT year, and then it gives 2024 through 2016. So that we're checking that they were correctly parsing the years out of this known HTML file. So why do we want to do testing like this? Well, more tests like this mean we can more confidently modify our functions, and then we can check if the tests still pass after modifying our functions. So typically what we do is we run our tests after every push to GitHub. This is called GHA, or GitHub Actions, or CI, continuous integration. And the idea then is on GitHub, we're going to get a report to see if the changes that we have pushed are compatible with our existing tests. So then we can be more confident about making changes that are not going to break any of our existing code. So if you look at my pull request, there's a bunch of other files too. So what is all this other stuff? So there's a bunch of other kind of boilerplate stuff that you have to put in a GitHub package, a GitHub repository to set up in our package. And so I'll briefly go over this stuff. First is kind of most importantly, the description file, which is like some package name, authors, and dependencies. So here is my name, and here's the description. National Strategy of Children's Health. I gave a link to the website where we're doing the interface with this data. Here we have a link to the GitHub repository. We also have imports and suggests. So imports are kind of the hard dependencies. Data table and NC are two packages that we need to have before installing our package. The suggest, this is like a soft dependency test that the testing framework. It's not required, but it could be like optionally interesting. If you want to run the test suite, you can install that package. The other file here, namespace, it defines imports and exports. So imports are functions from other R packages that we use in our functions. So here we have data table, which is a high performance in-memory database, R's secret weapon. So this is a really efficient way of doing data analysis, which I highly recommend. After that, we have NC, which is name capture regular expressions, which is useful for converting text files like HTML to data tables. And here in an R package, we use import from, not library. So here, import from NC capture all stir for parsing the HTML page using a regular expression. Import from data table, import from utils download file. So for downloading a file from the website. So exports are functions defined in our R package that we want to use in our R scripts. So here, there's currently one export get NSCH index, and that is that one function that we want people to be able to use. After that, there's another file, news.md, which is a human readable list of changes made to the R package. So you write it in Markdown, and it's output as a web page. So here you can write using this Markdown £sign for the first level section, £, for the second level section, star for a bulleted list, backticks for a code item. And so you can see that it's rendered for to a web page that looks like this on GitHub. And so this is how people typically write news files in our packages. And the idea is that you will describe for every different change you make, what did you change? And so here for the first change, I say, this is the new function that they added to the package in their first pull request. After that, there's a couple of other files. Not going to explain in a lot of detail, but there's a couple of files for configuration on GitHub. Inside of this ext data, there's some non-standard data sets like this datasets HTML file that I mentioned earlier. There's lists of files to ignore for building the R package or for Git version control. And then there's this build script to build and check the package. So that's pretty much all of the R package that I wanted to discuss. Are there any questions about anything inside of the R package before we go on to the next section about Git?
So I think about the R pack. When I think about R packages, I think about, whatever, the ones that are out there publicly that have sort of APIs tied to them. Like this sounds more generic. Like it doesn't have to have a rigid API. Is that a reasonable thing? Because it's tied to a paper, not to like a, I don't know. Does that question make sense?
Yeah. So your question is about if the R package needs to have like, is it interfacing with a data API, or is it providing an API for others to use? What exactly was the question?
Well, I mean, is this is a repository for a paper as opposed to a, like, I don't know, I've been so away from R, like, I don't know, what's a famous R package? Just name one.
Data table.
Data table. And I assume data table has the same sort of structure as this, right? In terms of the docs. But data table is like is an API, but this is a home for a paper. Do you know what I mean? That's the difference. And it sounds like that's cool and that all works, but I just wanted to kind of
not
clarify.
The same thing. Yeah, so this is definitely our package is an API in your idea. So you say it's an API, so it's like API means application programming interface. It means it's like some kind of interface that people can use our code. But for the paper, I recommend using this other kind of another repository here, like I said, like a lab notebook style repository like this. And in that lab notebook repository, we can call the API of our R package for doing the NSCH data processing. And so why do I say that? Because I think it would be good if all of those data processing functions were documented in a standard way so we all understand them. And then after that, for all the analyses that are really specific to the paper, I would put them all, like these figures that we're making for consistency. We could put them in a separate repository that's really focused on what are the results that we include in the paper.
Got it. Okay, thanks.
Does that make sense to you to split it up into two repositories like that?
Yeah, I think so. I think I get it. I think I get it. Like, I guess, does this thing exist? What's on the screen here? Does data table also have this thing on the screen? When they make an update to data table, they also have one of these saying, we added a new cool function.
No, I don't think so. So So here, this idea of like a lab notebook, this is just something that I suggest for academic papers, right? For our packages, I think it's a different thing, right? So, like going back to this slide, I usually organize my projects like this, where most of the code that's kind of like generic and could be used outside of the scope of a paper goes into a package, and then most of the code that's like really specific to your paper is just going to go into this like paper lab notebook repository. So
Okay.
the data table doesn't have any like paper associated, so it's just going to have this one repository and not the second.
It's more like it's more like the first one in the first bullet, not the second. Gotcha.
Yeah.
Okay. Okay. Got it. That makes that I think that clarifies my question. Thank you.
Yeah, that's a good question. Any other questions before we go on, guys? Okay, well, let's go on the second section about Git. So, Git commands. So what is Git? Git is a version control program. So a Git repository or repo contains all the versions of your code. And what is GitHub? GitHub is a free service for hosting Git repos. So it's the de facto standard for academic and open source code. And it makes it super easy to propose changes to others' code and to review those proposed changes in a web interface we call pull requests, so that the teams can better understand and maintain shared code like we need to do in this project. So the essential Git commands, I put 7 of them here. There are others, but these are the ones that we're going to use every day. And I've numbered them from 1 to 7. But here's a one-page summary of what they do. So git clone is a command that gives you a full copy of all of the versions of the code. The git checkout is for switching the current branch of the code. That branch is like your current version. There's lots of different versions inside of the repository. Number 3, git status and git diff, especially git diff is a really important one for checking what has changed before committing. After that, you use git add and git commit to tell Git what files to track and what to save inside of the repository. And then you use git pull and git push to download and upload changes to and from GitHub. So after you do all of these steps, then you can go on GitHub and create a pull request. And we've done all of this actually in this video here previously with Tim. So I provided the link here, and I'm going to kind of briefly go over the next section and really focusing on the number 2 and 3, which are kind of the most important steps, I think, for pull requests. So also, if you want to know more about all the other Git commands, there's this nice cheat sheet that RStudio provides, so you can download that and print that out if you're new to Git. And so that gives you kind of like a quick reference of all the different commands. Yeah, this slide is about installing. I'm going to use the Git terminal in the command line. You can install that by following these directions here. There's other interfaces. Some people like to use this GitHub desktop app. I like to use sometimes this Emacs Magit program. You can also have it directly in your RStudio or VS Code. But yeah, I'm going to use the basic commands, and so all the other interfaces should be somewhat consistent with that, but maybe with more point and click interface to what we're doing. So git clone, you get this on the GitHub webpage, you have a like URL here. You click on the code here in green and you get a URL, HTTPS. On Windows, you would copy that and then do git clone. Here I did git clone, and you can see that after that it says cloning into NSCH. And then we do CD into there, and then we do ls, and we can see that inside of the repository we have this readme.md file already. So it gives you kind of a copy of all of these files that are in the Git repository. Currently, there's only this readme.md. After that, I'm going to go.
Can I ask a question?
Sure.
You're not cloning into Toby Hocking you're not cloning into your personal GitHub space?
Good question. So your question is if I'm cloning into my personal GitHub space, and the answer is no. Here I'm getting a clone of this NAU ASD3 repository, and I'm getting a local clone on my local computer.
So this is okay. This is to your okay. This is okay. So this NA, sorry, gotcha. So this is just on your local machine. Okay.
Right. Yeah.
And
so
then, but
if
it's
you
going to
want
be
to get
tied to
like a
your.
copy of your of a repository that you don't have permissions for, that's called a fork. And so then it would go underneath your kind of like username here instead of the NAUASD3. But for this project, I gave everybody permission, so you don't need to make a fork. You can just do this clone command like I have here.
How will it know if it's my clone versus Tim's clone?
So everyone has their own clone on their own computer. And
then, but we're not. Okay, gotcha. So it's coming. Okay, sorry. It's down to, but when I push back up, I'm going to push back to the.
Right.
And I'm not going to push. I'm not going to first push to my MySpace on GitHub and then PR do the pull request from MySpace. I'm going to push straight to NSC. Yeah, gotcha. Okay.
Right. Yeah. So yeah, you're talking about your space. Yeah, you can have a fork of this repository if you want, but that's only for repositories where you don't have permissions. So here everyone has permissions, so we can all just work directly in the repository.
Yeah. Okay. Thank you.
And yeah,
I'm used to the other one. I'm used to the other one where I've got to push to my space on GitHub and then PR across, and it's a lot more complicated. This is a much smoother process for sure.
Yeah. So that's the way. If you have permissions, it's better to just everyone working in the same repository. And yeah, so then everyone has their own clone, and there's another clone on GitHub, which is kind of like the reference one that everybody's communicating. And then after that, we have Git checkout. So Git checkout is for switching branches. And so this is really, this is related to what you were just asking about, Dave. So a branch is a pointer to a specific version of the code. And there's different branches. So the main branch is kind of like the branch of the code that should always work, quotation marks here. Other branches should be for different fixes or additions to the code. So I created one that's called download-funds. And so if you were on the main branch here, we see on the prompt, we have main between these square brackets. I did a ls, and so in the main branch, we only see the readme.md. After that, I'm doing a git checkout download-funds. And then the main here in square brackets changes to download-funds. And then after that, I do a ls, and we see a bunch of other files in there. So what is the checkout doing? It's altering the state of your folder so that it's this new version or this different specific version of the code that corresponds to this different branch. So everyone can work on different branches. And so Dave, to answer your question, instead of working in your own like personal repository, you can create your own personal branch to work on. And then you're going to push that branch to the same repository. And so to create the new branch, we did this git checkout -b, and then you gave a name for your new branch, name of your new branch, and then you'll get a new branch that you can work on, and then you push your changes to that branch before merging it back with the main branch. Does that make sense? Okay. And yeah, so then if to go between branches, this git checkout command is really important. So the other thing that's really important, I think, when working with pull requests is here it says, now that you're on a new branch, modify some files and save them in your usual editor. And then once you save them, then what you want to do is you want to do git status to see what has changed. Git status is going to tell you here, oh, we've modified a file called readme. Okay. And then after that, you do git diff. Git diff is going to tell you, okay, what exactly are the lines that have changed in that readme? So here it says plus, 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 plus here to indicate we've added a bunch of lines. I added a section called related work to the readme. And so why do we want to use git status and git diff? Because when we're doing pull requests, we want to be very conscientious to only include changes that we want others to review. So we look at the git diff first to make sure that you want to include these 6 lines of additions that others will be reviewing in the pull request, because everything you see on the diff here is going to show up in the pull request, and somebody's going to have to look at it and approve it before reviewing. So make sure that everything that shows up on diff is only the changes that you want others to review and nothing else, because smaller diffs are much easier for other people to review. Does that make sense to you guys? Okay, good. Yeah. So after that, git commit is for saving, and then we do git push. And I'm going to skip over the rest of this stuff because we already did this in the video. So git push is for pushing the changes to GitHub. And then after that, we can do the code review. So I think the most important part in the last 30 minutes or so, I'm going to talk about how do we do the code review on GitHub after we've pushed our changes from our local machine to GitHub. So any other questions, though, about that previous section before we go on, about the different Git commands? I know I skipped over the last few, but like I said, yeah, if you consult that video, I think it should be pretty easy. And please, maybe we can schedule another one, but if there's more questions about just Git by itself, but I think it's more important to focus on GitHub right now. So after you put your changes, it's time to create a pull request. So we want other team members to review our code. So we don't push changes directly to the main branch, right? So like I said before, we're going to create a new branch, git checkout-b with some new branch name every time. And then we're going to commit and push to that branch, git commit and git push. After that, we can create a pull request on GitHub where others can easily review and discuss these changes before merging them into main. So then the team understands better the code on the main branch because all the code on main has been reviewed and approved by at least one other team member. And here I write a question mark more because, we could have a policy that, everyone has to review before we merge. But typically, in most projects, they say that at least one other person has to review and approve. So that's something that we can discuss. What is the kind of policy that we want? But the idea is that it's not just one person working on the code and that some other people can review it before they merge it into the main so that we can kind of have some kind of quality assurance or everyone on the team is at least somewhat understanding what's going on. So when we make a pull request on GitHub, it looks like this. You have this conversation panel where you can write whatever you want. I wrote this first PR provides a minimal R package with one function for downloading a list of currently available years of data. And then it says, Toby Hocking added 12 commits. And so each one of these lines is a different commit that I made. And next to each one of these commits on the right, you can see there's this check mark or in green or an X in red. And so this is when we use this GitHub Actions continuous integration. So the check mark means that all the tests passed, and the X means that there was something that failed. So the idea is that we want to have this kind of centralized checking system on GitHub to make sure that if we're making any changes to the system and to the functions, breaking anything that we're depending on. So that's a nice kind of feature that GitHub provides for us that the code is still working after we make changes. After that, the main place where we're going to be doing code review is this files changed tab. So inside of the files changed tab, it's a list of all of the diffs that have been committed in that branch, right? So it says TD Hawk wants to merge 13 commits into main from download funds. So main is the main branch of the repository. Download funds is another branch of the repository that I have proposed some changes in. And so what are these green lines? These green lines are a bunch of additions that have been made in the download funds branch that does not exist in the main branch. So you can go through this list of green stuff, and there's going to be red stuff for deletions, but mostly in the beginning of the project, you're going to have additions. But the idea is you're going to go through a list of all of this stuff, and you're going to try to understand, okay, what is Toby trying to add to the project? And then if you have any questions about it, you can ask here inside of this files changed. So here, for example, I scroll down to this file git nsch index.r, and for example, there's this code year equals list 0 to 9 square brackets plus as integer here at the bottom on line 11, right? Is that something that makes sense to everybody? Well, probably not if you haven't heard about regular expressions, right? So you can imagine, okay, I have a question about this line. So what do we do? You go to this little plus sign that appears next to the line, and you click on it. See this blue plus sign? When you click on it, you get this right box, this right comment box where you can write whatever comments you want. And it's going to be attached to that line that you clicked on. So here I write a comment that says, what does backtick square brackets 0 to 9 plus mean? And so that's going to be a comment that shows up. And you know, I can we can also go in and we can actually suggest improvements to code directly inside of this this web interface. So here I have selected lines 7 through 11 here in this page, and it gives me again this kind of write comment dialog box, and you see this little red circle that I put over this plus or minus sign. If you click on that plus or minus sign, GitHub is going to fill in a suggestion here. You see this big suggestion block? This big suggestion block, if you click on that plus or minus thing, it's going to be automatically like filled in by GitHub. And so the idea is it's just a copy of this code between lines 7 and 11. And then it's going to be able to, you know, you're going to be able to add suggestions very quickly. Here, I'm going to give a demo of this because I think it's probably easier to understand when we're actually seeing a live demo. So here I'm going to our NAU ASD3 repository. We go to this repository that we have our R package. We go to the pull request tab. Here, I'll make the text bigger so people can actually read. And here, that pull request here is this one. I go to the files change tab, click on the files change tab, and then I go down to, for example, you know, that that R code that we were just looking at, where here we have that regular expression here. If I just click the plus sign, I get a comment box, right? And then if I click this plus or minus thing, what happens? I get a suggestion. And the suggestion, it's just a copy of whatever I clicked on. And then I can kind of modify this. And if I have a like something, you know, I want to change. Maybe we want to change the variable name. I don't know. New. And so if we add a comment like this, it becomes what's called a suggestion. And in the suggestion, why is that interesting? Well, somebody can actually just propose like a new version of the code. If they don't like what I proposed, then they can say, okay, this is what I propose instead. And then we can directly commit those suggestions. So that's a nice way of working together on these pull requests. If you want to do more than one line at a time, you click the plus and then you drag it down like that. And then after that, you can do this plus or minus thing, and it's going to give you a copy of that whole block in the suggestion block, so you can suggest changes to a whole block of code. Are there any questions about that? Is this the first time that everyone's doing this, or is it new have some people done this before?
Yeah, for me it is new. Yeah.
All the sexy bells and whistles are new. This was not here a few years ago when I was last doing this. So pretty fancy now.
Yeah, I think it's it's come along pretty good in the last few years. You're right, Dave. But yeah, anyway, so you don't have to use all of these like fancy things, but the idea is that at least you're going to be reading the code, and at least you have some way of saying, if you have a question or a suggestion to improve some of the code, you have a very easy way of doing it. And when you do it, you know, you can read a question like, what is this? You know, and I'm going to just add a single comment here. And what's going to happen is if you go back up to the conversation, in the conversation, you know, if you scroll down, the most recent comment probably is here. I just commented, what is this? And so you'll have a comment and it's actually showing you the relevant context of the code that you were asking about. So it's really quite, you know, a nice, easy interface for people to ask questions and revise and try to understand this like shared code. Any other questions about the interface before we go back to the slides? Okay, I'm gonna delete that comment again. Delete. So yeah, just when you go to the pull request page, definitely always click this files change. This is like your go-to place for code review. You want to do a code review, do your, you know, ask some questions here, and then when you're done, you do review changes, and here you can take either approve or request changes. Here I can't click on it because I'm the one who proposed the pull request, but anybody else looking at this right now will be able to either approve or request changes. And so please click on the approve or the request changes depending on if you think it's good to go or if you need me to change something. Okay.
Can you show how to get the side by side? I can never find this. Where you've got one
side by
has got
side.
Well, like the left side has the original code and the right side has the new code. Because this is the one that's sort of the one, like where you can look at the, you know what I'm saying? Like you can see exactly how it fit, and I can never find that button.
I think it's here. This little gear up here.
Uh-huh.
I think it's this one. But I don't think it's really super interesting here.
Yeah, because everything's
we don't have any deletions, right?
Yeah, that's exactly right. It's so cool when you have deletions and additions and you can see the old and the new.
Yes,
okay.
So that would be here. You go to this
I don't think it was that
either
easy
unified
before.
or split. Yeah.
Thank you.
Yeah, no problem. So let's go back to the slides. We have a few more minutes to maybe talk about a couple more points about GitHub. So yeah, I talked about these suggestions. You can click this commit suggestion button to actually you know, apply the suggestion after others have reviewed it. And then here I talked about this approve or request changes button. So these are how you indicate to your colleagues if you think it's okay to merge to main as is, or if you want them to change something first. And then the final step is you click this merge pull request button at the bottom of the pull request, and then that will merge all the changes into main. So when all the checks have passed and at least one other person from the team approves your PR, then you can click this button and then all of those changes get merged in, and then you can start working on something else in another branch and another pull request. And I think that's it. So, you know, I said, why do we want to do R packages? And the reason is because we can document the code in a standard format, making it easier for others to discover your code, how to install it, how to use it, and how it works. And so why do we use GitHub? Makes it easier for others to review your proposed changes and ask questions, suggest improvements, so that teams like ours can better understand and maintain our shared code. So that's it. I think we can take questions in the last 10 or 15 minutes if you guys want.
Do you always need to use a branch? So if I'm working in main on my local machine, can I PR directly, or does that make sense? Or do I have to make a branch?
Yeah.
If I want to submit a PR.
That does make sense. So yeah, so the question is, can we ever work in main, or do we always have to create a branch locally? And the answer is, basically you should always create a branch. If you're working in main, that means that you're not going to be able to make a pull request. So that's okay if you don't want anybody else to review your code. But mostly I think the idea is that we do want everybody else to review our code. So you do want to create a branch every time for everything.
Okay. Okay. That's okay. Because we all have write privileges to the repo, if I start working in main and I do a push, it's just going to go into main and bypass it's going to bypass the PR process.
Yeah, that's just going to be a change that you don't want other people to review. And that's okay, but I think most of the time we do want other people to review.
Yeah, no, I don't think I probably should be 0. Anyways, I think we want everyone to review, or all pushes to be reviewed, right?
Yeah. And what do you think about a policy? I tried to, so what I did so far, going back to GitHub here, I created a couple of teams. So here, Python reviewers and R reviewers. So I put 3 people in this one, Sai, Chris, and myself. And then in Python reviewers, I put Dave and Ben and myself. And I think the idea would be for every pull request, we could have one person on the corresponding team review. Does that make sense? Or do we want everyone on the team to review?
No, I think I would vote for 1.
Yeah, I think 1 is probably enough too. That's why I proposed that. Yeah, all of this maybe seems a little bit like complex, and if you've never done any of this before, it's like really maybe intimidating. Let me tell you though, it gets to be very natural and very fun. I don't know if I would go as far to say fun, but at least it's like it just makes it so much less of a hassle to review other people's code when you can do it in this nice pull request interface. And you can see these inline comments and the exact line of code that you're talking about. It just makes it very easy to discuss the changes. Were there any questions about this particular pull request that I submitted? Like all of this stuff. Is there anything that's blocking you guys from approving? I see. Have you created the rule to enforce this? Actually, I did. You can create a rule so that here, before emerging any PR, there should be one other project member that reviews or approves the proposed changes. So I did create a rule for it, but I left it disabled for now. And I feel like maybe we could just use the honor system. And if it doesn't work, then we can like start policing. But do we want more specific guidance on how to increment this version number? Yeah, we could. Yeah, if you want to, that's fine. Usually I just use version numbers based on the date, which seems to always go up. And so you have an interpretable way of understanding this is the date that we created that version of the software. But if you want a different way of doing it, that's fine. Here, I got a couple of comments from Sai here about the code. But yeah, I didn't get anybody to approve yet, so I'm not going to merge it until somebody approves. Is there something that's blocking somebody? I mean, are there any things about this code that I need to clarify before I merge?
Or maybe another question: Sai, do you need more time? Or Chris, do you need more time?
No, I went through and made some comments, but I just approved it now. I mean, it works. It looks good. Again, there's a few questions, but they don't need to be resolved to approve this and merge.
Okay, well then let's just give a demo of how this works then. Okay, so we go back to conversation and we go over here and we see, okay, have you created a rule to enforce this? I'll just write a comment. Yes, but it is not activated yet. Okay. Here would be a good place to actually use the suggestion. So why don't we just do that as like a quick demo right now? So here, like, for example, here, going to that comment that you just made, it was on the news. Here, I'm going to go back to the other way because we have space. It was on the news.mbd. So, right. So here you made a comment about, no, it was no contributing.md, right? You made a comment about how you created a role to enforce this. And you say, do you want more specific guidance on how to increment the version number? So here I go to reply, and then I go to add a suggestion. And then it gives me a copy of that line of code here in the comment box and says, and then you could say based on the current date, right? And then you say add a single comment, and then you get this commit suggestion or add suggestion to batch. So I'm just going to commit suggestion and say date based version. Okay. Commit message, commit changes. And so what happens then is it's actually going to go and it's going to edit the code that's in that branch. So now, right here, where does it say? Increase the version number in news.md and description based on the current date. And we see that comment disappeared because we already committed that suggestion, right? I recommend the PR clearly identify somehow whether the PR is bug fix, feature, or documentation update. Great, let's do that too. So please indicate in the PR title. Does that make sense? Whether the PR is bug fix, feature, documentation update, etc. Yeah. Okay, then we do add single comment, and then we do commit suggestion again. PR title. Okay. Commit changes. And so now all of these changes that these two suggestions that we did, it's only happening on the download file funds branch, right? If we go back to the main branch here, we still see there's nothing happening here, right? You have to go to the download funds branch here to see all of those changes. Actually see the most recent changes, this PR title thing that we just did in the suggestion box, right? And now I think, am I right that, are there any more outstanding comments that I need to resolve on this PR, or are you okay? You said
I got a question here.
Yeah.
So can you push this PR? Can anyone do the commit thing that you just showed us, or only you?
Yes, anybody can do it.
And so then does that mean that the branch on GitHub is now out of sync with the branch on your local machine?
Right. Yeah. So now I need to pull those changes from GitHub back to my local machine.
But if you were just going to delete the branch, it wouldn't matter. You could just delete it and be done with it.
Or I'm going to merge it now. And so now I don't really even care about that branch anymore. I'm just going to go create a new branch.
Yeah, for the next thing. Okay.
So I do have an approval, and I didn't really change anything substantive. So I guess the check is going to still work too. So I'm just going to merge it so we can see how that works. And we can, in the tutorial like that, merge pull request. And usually the default here is okay. I think, there's some question about what is the kind of merge to do. I like the squash and merge, because then we just get one commit that corresponds to all the changes in the PR on the other branch. So squash and merge. And then here it's got like a bunch of messages that I usually delete. So the commit message will be add get NSCH index plus package setup. Number 1 refers to the pull request number. And then I do confirm squash and merge. Pull request successfully merged and closed. You're all set. You can safely delete. So I delete. And then after that, if we go back to the home page, you see that we just have that as the kind of like most recent commit. And now we have all of these nice files that were only present in the branch, but now they're present on the main branch. Does that make sense, guys? Okay, I see thumbs up. That's good. So any other questions before we stop now? Because I think we almost out of time.
No questions. Yeah. Actually, this is just a Do we want / need an issues.md? I think I saw somewhere earlier that we refer.
Like a template, you mean?
Yeah.
I didn't make one yet, but if you want to, that's fine with me.
Okay.
Yeah, what Chris is talking about is like issues. If you click new issue, you just get kind of a blank page. But if you provide an issues.md file, you can actually have something kind of like a default template for people to fill out if you want. I think that's maybe overkill for right now in the project.
Because this is internal. Yeah, this is internal to our team. But I think the issues page is a good one. So
yeah,
if anybody's new to this, yeah, you can just start a blah 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 here. And
yeah, it's a to-do list.
Yeah.
And so, yeah, so here's a to-do that I made. I want to have like the ability to download the different stata files and convert to CSV. And so it says it involves functions. I give a reference to these 3 pull requests. And note that I created a bunch of pull requests like all at the same time that hopefully don't conflict with each other. So, you know, feel free to just like work on as many pull requests as you want. Hopefully each one is like not making changes to the same files you can, but then you have to do a merge conflict. But I don't want to talk about that right now.
No one wants to talk about that.
Anyway, I got to get going to another meeting, guys. So I hope that this was all useful for you, and I hope that I'm not just like R geek that's going to be the only one hacking this code. I hope that I can get some of you guys on board with this.
I think I would add really quick, like what we just talked about the conflict. You need to be pulling back from what's on GitHub regularly. So you're working on the most current version and having small pull requests up and approved. Because if you don't do that, you're going to start having conflicts, and merging conflicts is a nightmare. So please commit often, I guess.
Yeah. Indeed. I did have a slide about that. Going back to the slides, just very quickly, you know, we have a, where is it? Git push? No, git pull. Yeah, so, you know, when you do a git pull, you have to do that before you push. And if others modify the same lines that you did, then you have to decide which modifications to be kept. That's called a merge conflict. Staying calm, breathe in, breathe out. It will be okay. Just edit the files, save them, and git commit, and then hopefully everything is fine. So also feel free to contact me or write, you know, on email or on GitHub issues is the best way. And I'd be more than happy to help you if you have any problems with any of this stuff. So I'm going to stop doing the screen share. I got to get to another meeting at 1 o'clock now. So please share the video. I don't know if you can just put that online, but
yeah,
I would appreciate that.
I'll upload that into our machine learning analysis folder on Teams.
Okay,
Thanks. Toby, for putting all this together. Super helpful.
Thank you so much.